In this video, I'll be talking about resolution of vectors. So, what is resolution of vectors? Let me show you with a quick example. Now I have a few markers here to indicate the positions, and we'll be using this box to, show the movement. So first up, let me create a start position. Let's take it from here. So assuming the object will start from here, right? So why not keep it this way? Okay, so it starts from here, and let's say it goes to here. um let's take here for example. So now we can just say we can put a force like this and make it go here. That is one way of doing it, where the force is coming at an angle, where this is one axis, the x-axis, this is y-axis, and this angle is theta. Or we can just say two forces, which is one pushing for the y-axis and one pushing for the x-axis, work together to make it go to in the xy axis, so that it reaches from origin to the final destination. So let me explain the theory of this now. So now that we have seen an example of how resolution of vector works, let me explain it on paper. So we have a graph. Let's take this as x-axis and this as y-axis. So there is this force which goes like this, and let's call it, for now we'll just call it c vector. I'll get to why I named it c later. You'll just find it easier, but sure, as of now we'll call it c vector. And the angle between the x-axis and the c vector, let's call it theta. Alright, so there's this vector on a Cartesian plane which goes in a direction or angle theta. So now in the example as I've shown, the c vector can be done by putting one vector upwards or forward, backward, whatever you want to call it, and one vector sidewards. So this c vector right here is a combination of, let's call this a vector and let's call this b vector. So it's a combination of two forces, that is one in the y-axis and one in the x-axis. So this diagonal is dependent on these two. So now let me just explain why, how. So if you've been observing, there is a formation. So if you take this, there is a right angle triangle being formed. Alright, so this is corresponding to the y-axis here. This is the x-axis. So this y value will come here and this x value will remain here. So there is a right angle triangle being formed. And now since a right angle triangle is being formed and we know our angle and we know the c vector, we need to know this and this. So to know that, we'll be using the trigonometric ratios sine and cos. So how exactly? Let me explain. So first up, we have c vector times sine theta is a vector. So how? So again, let me draw the Cartesian plane, c vector. Oops, let me just draw that a slightly better diagram. Okay, and a c vector right here. It is forming theta. So this height right here is of this here. So this is the, let's call it a vector for now. So a vector is the one in the y-axis for simplicity's sake. Okay, so this is c vector. So this height right here will again be a vector. Alright, and now we have b vector here. So what is sine theta? Sine is basically opposite by hypotenuse. So for sine theta, theta in this case is this angle here for us, we'll be using the opposite. The opposite to this angle is a vector. So a vector times by c vector, that is the hypotenuse. So c vector times sine theta will give us a vector. Now again, similarly we can split b vector as well. So again, let me just put this up here. This is a vector, this is b vector, this is c vector. All right. So c vector times cos theta will give us b vector. So how? Well, cos is basically adjacent by hypotenuse. So the value for theta, again, this is theta here. So cos of theta is basically adjacent, that is b vector, which we don't know, divided by c vector, which we already know. So c vector times cos theta will give us b vector. So now we have our b vector here and our a vector here. So now we can split a vector in a direction theta, assuming this Cartesian plane, well, it's not probably drawn, but fine. So assuming this is vector in a Cartesian plane that is moving with an angle of theta, we can split it into two vectors, that is, well, on the x-axis and on the y-axis. So that concludes the resolution of vectors as of now. So next we'll be checking how to add these two to get this. So now that we have a vector and b vector, we need to be able to get c vector, right? So we need to add a and b to get c. I'll be talking about that in the next video. So thank you for watching.